The coelacanth is a deep-sea fish often referred to as a living fossil because it was thought to have gone extinct around 66 million years ago, until a living specimen was discovered in 1938 off the coast of South Africa. This remarkable fish belongs to the order Coelacanthiformes, which dates back over 400 million years, making it one of the oldest known lineages of lobe-finned fish. Coelacanths are easily recognized by their thick, scaly bodies, lobed pectoral and pelvic fins that resemble primitive limbs, and their deep blue or brown coloration with irregular white spots. These fish can grow up to 2 meters long and weigh around 90 kilograms. Unlike most modern fish, they have a hollow, oil-filled backbone rather than a solid spinal column, which helps them remain buoyant in the deep sea. One of the coelacanth's most fascinating traits is its unique fin movement, which resembles a walking motion similar to that of land vertebrates. This has led scientists to believe that they may share a distant evolutionary link with tetrapods, the first vertebrates to transition from water to land. Another rare feature is their rostral organ, a specialized electroreceptor in the snout that helps them detect prey in dark, deep-sea environments. Coelacanths live at depths of 150 to 700 meters in underwater caves and volcanic slopes along the coasts of South Africa, Madagascar, Indonesia, and Comoros. They are nocturnal hunters, feeding on fish, squid, and other small marine creatures. Unlike most fish, they give birth to live young rather than laying eggs, with a gestation period that lasts about 5 years, one of the longest among vertebrates. They are classified as critically endangered by the IUCN, with only a few hundred known individuals in the wild. The ocean sunfish, the giant of the open sea, is one of the heaviest bony fish in the world, reaching weights of up to 2,300 kilograms and measuring over 3 meters in length. This strange yet fascinating creature is known for its flattened, disc-like body, large dorsal and anal fins, and tiny, rudder-like tail. Unlike most fish, it lacks a traditional caudal, tail, fin, using its powerful fins to move in a distinctive wobbling motion. Sunfish are typically found in temperate and tropical oceans worldwide, spending most of their time near the surface, basking in the sun, hence their name. This behavior helps them regulate their body temperature after deep dives. Despite their enormous size, ocean sunfish primarily feed on jellyfish, as well as plankton, squid, and small fish. To sustain their massive bodies, they must consume large quantities of low-nutrient food. A unique feature of the sunfish is its thick, mucus-covered skin, which can be up to 7.6 centimeters thick and hosts a variety of parasitic organisms. To remove parasites, sunfish often visit cleaning stations, where smaller fish like wrasses and even seabirds pick off unwanted hitchhikers. They are also known to leap out of the water, possibly as a way to shake off parasites. Despite their gentle and slow-moving nature, sunfish are prolific breeders. Females can lay up to 300 million eggs at a time, making them one of the most fertile creatures on Earth. Their larvae are tiny and look very different from adults, going through several transformations before reaching their massive size. While harmless to humans, sunfish often get tangled in fishing nets and are frequently struck by boats due to their habit of drifting near the surface. They are considered vulnerable due to bycatch in fisheries, habitat destruction, and pollution. Despite their awkward appearance, ocean sunfish are remarkable survivors, perfectly adapted to the open ocean ecosystem and continue to captivate marine biologists worldwide. The sea sapphire, nature's living jewel, is a tiny, otherworldly crustacean belonging to the copepod family, known for its breathtaking iridescence. These creatures, measuring just 1 to 2 millimeters in length, are found in the open ocean and exhibit a dazzling display of colors, ranging from blue and purple to gold, depending on the angle of light. Some even seem to disappear completely, making them one of the ocean's most mysterious inhabitants. The secret behind their shimmering colors lies in their crystal-like skin structures, which manipulate light through a phenomenon called structural coloration. Unlike pigments, this effect occurs due to microscopic layers in their exoskeleton that selectively reflect certain wavelengths of light. This allows them to shift between visible and invisible states, making them nearly undetectable to predators in open water. Sea sapphires are planktonic, drifting through the upper layers of the ocean, and are commonly found near Japan, South Africa, and the Americas. They play a crucial role in the marine food chain, feeding on microscopic algae and detritus while serving as prey for larger organisms like fish and jellyfish. One of their most fascinating traits is their gender-based visibility. Males display the striking iridescence, likely to attract mates, while females remain transparent. Some species of sea sapphires are also known to exhibit bioluminescence, adding to their ethereal, jewel-like appearance. Despite their microscopic size, sea sapphires continue to capture the attention of marine biologists and ocean enthusiasts alike. Their ability to manipulate light not only aids in their survival but also holds potential for biotechnological applications, inspiring research into invisibility technology and advanced optics. These tiny, glittering gems of the sea remind us of the ocean's endless wonders and hidden beauty. Siphonophores, colonial drifters of the deep, are a group of marine invertebrates related to jellyfish and corals, belonging to the Cnidaria phylum. These fascinating creatures, which include the well-known Portuguese man-o' war, are not single organisms but colonies of specialized individuals that function together as a single entity. Each zooid has a specific role, such as movement, feeding, reproduction, or defense, making siphonophores one of the ocean's most complex colonial organisms. They are typically long, gelatinous, and bioluminescent, with some species reaching incredible lengths, such as Praia dubia, which can grow up to 40 to 50 meters, making it one of the longest animals on Earth. Most siphonophores drift in the deep sea, using their tentacles lined with stinging cells to capture small fish and plankton. One of their most striking features is bioluminescence, which they use for communication, luring prey, and defense. Some deep-sea species produce mesmerizing blue and green light displays to confuse predators or attract food. Unlike jellyfish, siphonophores move using a gas-filled float or pulsating jet propulsion generated by some of their specialized zooids. Despite their delicate, fragile bodies, siphonophores are efficient hunters, with some species using fishing line tentacles that can stretch for several meters to snare unsuspecting prey. However, they are also highly sensitive to environmental changes, making them an important indicator of ocean health. Rarely encountered due to their deep-sea habitat, siphonophores remain one of the most enigmatic and alien-like creatures of the ocean, showcasing the incredible diversity of life in Earth's waters. The immortal jellyfish, the secret to eternal life, is a tiny, transparent jellyfish with an extraordinary ability. It can reverse its aging process, effectively making it biologically immortal. Native to oceans worldwide, especially in warm tropical waters, this remarkable creature measures only about 4.5 millimeters in diameter, yet it holds one of nature's greatest mysteries, the ability to cheat death. Unlike other jellyfish that die after reaching adulthood, Turritopsis dohrnii can revert back to its juvenile polyp stage under stress, injury, starvation, or old age. It does this through a process called transdifferentiation, where its mature cells transform into younger cells, essentially starting its life cycle anew. This ability allows it to theoretically live forever, barring predation or disease. The life cycle of the immortal jellyfish starts as a free-swimming larva, which settles on the ocean floor and develops into a polyp colony. Instead of dying after reaching adulthood, the jellyfish can transform back into a polyp and regrow into new jellyfish multiple times. Although tiny and often overlooked, the immortal jellyfish is one of the ocean's most extraordinary survivors, challenging our understanding of aging and the limits of life itself. Despite its potential biological immortality, Turritopsis dohrnii is not invincible. It is still vulnerable to predators, infections, and harsh environmental conditions. Scientists are fascinated by this jellyfish because its ability to reverse aging may offer clues to human medicine, tissue regeneration, and longevity research. Thanks for watching. Please subscribe for even more viewing pleasure. Don't forget, like and comment. Feel free to share.